Good evening, dear participants. Am I audible? Is my screen properly visible? Participants, can you please confirm so that we can start with today's class? Okay, thank you. Thanks for the confirmation. So I hope we can start with today's class. So this is Naan Mudhalvan Virtual Internship, and this class is Data Science, and it is day 9. I welcome you all on behalf of pantech elearning. So we are in nearly half of the stage, right? So totally it is a 20 days class, and we are going to complete nearly 10 days. Today is day 9. So we are in the middle of machine learning. So we have just started. In the past 2 days we are seeing about machine learning regarding the introduction, and then the data pre-processing tools we have seen. So in yesterday's class we have covered majority of the topics in pre-processing. And remember guys, do you remember what are the things we have seen in previous class? So in the pre-processing, when you come into that, we have seen about the scaling, which is nothing but standardization, normalization, robust scalar. And then what all topics we have seen in yesterday's class? We have started with encoding the value. We have seen, right, nominal, ordinal encoding. Remember, then what all we have seen? And then about imputing the null value with the help of sklearn, their types, and then moving into finding the outliers. So with that we have completed yesterday's class. So we have seen till about how to find the outliers. Okay. So in today's class we'll just refresh a little bit about finding the outlier, and then we are just going to continue with how to handle the outlier. Okay. So once we complete that, we are going to see about train test split, and that will be a little part only. So once we complete that also, we are going to go into feature selection. So that will play a majority role in today's class. Okay, that's very important, and we are going to see 5 to 6 methods with which you can select the important features. Okay, I'll tell you about it. So we'll start with today's class with in machine learning. So the pre-processing, we have completed the feature scaling, encoding, imputing null value. So we have completed till outlier detection. Okay, so regarding the outlier detection, there are two methods I have told you. One is z-score method, another one is IQR method. So we have seen in yesterday's class, right? So finding with the help of threshold value 3, so if it is greater than 3, we have created a function for it and take the outliers. Like this, right? We have did it, right? Take the mean value of standard deviation, subtract it and divide by standard deviation, and then if the score is greater than 3, which means it is an outlier. And then there is an IQR method which is based on percentile. Okay, this will be best if you have any skewed data. I told you right in yesterday's class. And this will find the outliers based on the quartile, the 1.5 plus Q3 into IQR or minus below that. So with this we will be having a lower bound and upper bound value. So apart from these two, if it is inside it is a normal value, if it is outside it is an outlier. Like this we have found the data. So now we'll see about, okay, this is a normal Gaussian distributed data, this is a skewed data, okay, towards left and right. So which methods you should use? If your data is Gaussian distributed, you have to go with z-score. That will be best to find the outlier. Why? Okay, so if you have any most of outliers, or if it is skewed towards one or other end, then if you go with z-score, then the mean value and the standard deviation will be very far, so it will affect the values. So in that case you can go with IQR because it is based on the percentile, so the outliers won't affect or have any impact in this IQR method. Okay, so based on that you can choose which method you are going to use. Now going into outlier handling, so it's very simple. You have 3 options. So the first one will be trimming. So trimming is something like removing the outliers. So if you have outlier, you can just remove it by using the function what all you found. Like we are searching for outlier, right? Once we found that, we can just eliminate them. But it is not a good task because every data is important for you. Okay, so it won't be a better idea to remove that. Okay, if you are having many outliers, you cannot just go and remove them. So in that case, you can go with these two options. So one will be known as capping, and next will be imputation. Okay, so capping, what it is, setting a minimum and maximum value and replace the outlier. For example, I am having a lower bound and upper bound value, right? So what I'll be doing is, see here in this image I'll show you. For example, imagine this is a lower value, this is upper value. If it is lower than this value, it is outlier, right? If it is higher than this value, it is outlier. So I'll be using, what I'll be doing is, I'll check each the value. If it is inside this range, I'm going to leave it. If it is lower than this value, what I'll be doing is, this value will be much lower, right? So I'm going to replace it with the lowest value. Okay, if it is higher than this, for example, if the highest value, so what I can do is, I can replace this 200 with 100. Okay, I can set a maximum value, and whatever greater than that, I can replace it. So that's what this capping will do. Okay, so next is imputation. So this term we have seen, right? What is imputation? Imputation is manipulating the value. So if you have null value, we can impute it based on other features, right? So we have seen how to impute based on some library we have seen, right, in yesterday's class. So you know how to impute a null value based on the other columns. So what you can do is, if the value is, if it is an outlier, you can just turn them into a null value. Okay, we can remove it, that particular value alone, and turn them into an outlier, into a null value. So once you get the null values, you can go and impute them and replace with some other value. So that's how this outlier handling will going to be. First we'll go with capping. Okay, so I'll show you how to do it. Can you see it, guys? Is it clear till now what I have given? Can I get thumbs up in chat box? Can we start with this one? Waiting for you guys. Clear? Okay. So I'll go into collab. So I have this previous day's file. So I'm going to continue with it. Here in this variable lower and upper, we got some value which is the lower and upper bound. So with that we have filtered it, right? This is based on IQR method, based on the Titanic age column. Okay. So what I'm going to do is, I'm going to use this lower how to do capping with the help of this IQR method if you've done that. So I'll go with Titanic, that variable dot far column, okay, and in that Titanic dot far greater than upper bound. Okay, so value which is greater, I'm going to get that alone. See here, these are the things. Totally 118 is above the upper value. Okay, and when you go for lower, what you can do, you can check with what are the values which is lower than that, less than lower value, lower bound which we have created. Okay, there is no lower bound for this, only upper bound. So what I am going to do is, in this equal to upper, so whenever it is greater than this value, upper value, I am going to replace it with upper value. So what is the upper value? I will print upper. So it is the IQR method, we have found the upper bound, it is this value. Okay, so now I am setting this to upper. So wherever it is greater than that value, it is going to be this value. Okay, so now if I go and check this one, I can't find anything because now we have replaced it. So it won't be greater than the upper value, empty. So if I want to check it, what it is equal to, wherever it is equal to upper, and you can find all those 118 where now it is replaced with that upper value. Okay, this is one method of capping. If it is lower than that, you can check that and replace that also. Clear? Clear with this one? And for example, if you are done with Z score, okay, this is IQR method, you have found the outlier and you replace it. Now here, see here, this is Z score method, right? We take the mean, we take the standard deviation, and we get this value. If it is greater than 3, we are doing this one. Okay, if you done this, okay, for example in far column, if you do this, okay, how to handle this one, how to handle this kind of outlier. So there is separate formula for this. I am going to create a function here, define handle underscore outlier. Okay, so I am going to get the data here. So I want actually the mean value, mean equal to data dot sorry, it is np.mean using numpy.mean. I'll pass the data inside, and the standard deviation np.standard, the data inside, and the maximum value. Okay, here there is another formula. If you go with this one, you can go with mean plus 3 multiplied by standard deviation. Okay, so this will be the maximum limit, and for minimum limit you can go with mean minus 3 multiplied by standard deviation. So these will be the maximum and minimum value. Okay, so for this what I am going to do, I am going to check it here itself. The data I am getting, the data less than minimum underscore value. If it is less than, I am going to replace it with minimum value. Okay, the capping we are just doing like we did above, and we are getting the minimum and maximum value with the help of this formula, since it is an z-score calculation. Okay, so the data where for greater than maximum value, it is maximum, right? Sorry, greater than minimum equal to maximum. Okay, so once I done all these things, finally I want to return the data. Okay, this will be the function. So let me run this. Now we have to call the function. Okay, so outlier equal to, so I'll call this handle underscore outlier. Okay, I have to pass the data. Let me pass Titanic in that fare column. Okay, it's done now. Okay, you can go with Titanic.max, sorry, the fare column, or you can go with this one, out.max. Okay, this is the value, it is the maximum value, and it is replaced now. Okay, so if you want to find the minimum value, you can go and check that also. So for example, if I copy this, so the outlier now will be replaced with this value. Okay, see here all the 118 outlier with this method, with the help of minimum and maximum value, you can see it both find 118 value. Okay, and we replaced it. Clear? This is what the outlier handling will do. If you want to go with null value, okay, imputation, if you want to create a null value, you can do it with the help of numpy.nan. It is going to create null value. For example, I'll copy this thing. Instead of giving it as minimum and maximum, np.nan, so it is going to replace the outliers as null value. Okay, so now let me reload the data set so that we can get the null value, or I mean the outliers again. Let me run this, and for example, this is which column? It is fare column, right? So Titanic dot fare dot is null dot sum. So first let me check for null value in that column. It is 0. So now I am creating a null value whichever it is outlier. Okay, Titanic dot fare column. Let me run this. Okay, so I have to create a variable here. Is null dot sum. Okay, now we got 42 null value. How we got it? So those are outliers. It is found as outlier, and they have been created as a null value. So now you got a null value, and you know how to impute it. Okay, there are known as simple imputer, KNN imputer, and iterative imputer, right? We have seen in yesterday's class. So with that you can handle the outlier. Okay, so we have completed about the outlier, and we have completed the data collection, pre-processing. Now we are going to start with train test split and feature selection. Can we start it, guys? Is it clear till now? Any doubts? Okay, so we'll start with train test split. So the next step is train test split. So what it is? So in machine learning, the train test split is a technique. Okay, it is used to evaluate the performance of a predictive model. So the next step will be, after this we are going to give it to the model, right? Once we do all the processing of the data, it is going to give it to the model to do some statistical task. So if you want to do that, okay, we are using something to evaluate. So that is known as train test split. So it is like the basic exam, okay, we are having, right? So the basic idea is to split the available data into two parts. So the one part will be train the model and other part is for test its performance. So how it is happening? See here. For example, imagine this. I am having totally 10,000 rows in my data set, okay, 10,000 rows. So what I'll be doing, or simply imagine I'm having 1,000 rows in my data, 1,000 rows. So what I can do is, see here, I'm splitting the test size as 20. 0.2 is 20%. So 20% among this 1,000 row will be what it is 200 rows, right? So the 200 rows I'll keep for testing, okay? And remaining 800 rows is for training, okay? And what we are doing is, I'm splitting it as X train, X test, Y train and Y test. You know what is the training part? Training part is the majority of the part which is for training, and just 20% for testing, that will be test. So we are having X and Y here, right? So what is X, what is Y? X will be the features, Y will be the output the machine want to predict, okay? X will be the feature, Y will be the output the machine is going to predict. For example, see here, this data set. Do I have Titanic.head here? Okay, so this is the data set, right? And finally we will be predicting whether the passenger is survived or not. It is 0 or 1, that is the prediction here we are doing. Or whatever may be the prediction answer may be. This is the answer, this will be the Y. Imagine as an answer. And all these remaining things are question. So the machine learning model, what it will do is, it will learn for these question, the answer is 0. Or for these question, the answer is 1. So it is going to keep on learning. Okay, in the training part, what will happen is, in the 800 rows, it is going to learn if this is the question, this is the answer. So I'll be giving the X train and Y train. Okay, 800 question, 800 answer to the machine learning model to learn. That will be the training part. So once the training is done, okay, I'll be go for testing. So how will you give a test for a student in school? So you'll be giving the question, okay, the student will write answer, but the original answer will be with you or the teacher, okay. So the question is X test. This is the test question which is for the student. So this contains 200 X value, but the Y value we'll be having with us, not giving to the machine learning model. So I'll be giving this X test alone to the machine learning model to do test. So it will give some answer. So it had learned from this 800 row, right? So in this 200 row, it is going to give answer. Okay, it will give 200 answers. So now you have the original answer and the answer given by the machine. So what you can do is, you can compare both of it and how much marks it got. So that's what the metrics, okay, that's what this thing. Evaluate and improve. Okay, we'll give it to the model, ask it to train and then give the prediction. So you can evaluate. If the score is 80%, you can go with some other model or change the tasks. If you got 90% correct, then you can go with 90% model, right? So that's how this step train test split is helping. Clear about it? So to do this, you have to pass the X and Y value. X will be the feature, Y will be the output or answer. So you have to mention the test underscore size. If you mention 0.2, it is 20%. Like if it is 1000 data, 800 for training and 200 for testing. If you mention 0.3, it will be 700 for training and 300 for testing. And there is something known as random state. I'll tell you about it. So for this, you have to create 4 variables. So from sklearn.model underscore selection, this is from model underscore selection, import train underscore test underscore split. Okay. So X train, X test, Y train, Y test equal to train test split module, X, Y, test size, random state. So what this random state is doing here, see here, these are the parameters you can pass in this X train test split module. This is from the scikit-learn documentation. Test size we can mention, X and Y will give, okay. So train size will automatically take. If it is test size, it is going to subtract it with and give you the train size, no issue. The random state. if you didn't mention random state, so whenever every time you run the value, okay, every time you run it, so it is going to split them differently. Okay, so if you set some random state, it is going to split in that same manner. Okay, it is better to mention the random state, so every time you run you will get the same output. Okay, otherwise this random state, if it is none or if you didn't mention it, every time it is going to take a different 200 rows, so that will like it will change the output or result. Okay, if you want to take the same manner, whatever the 800 taken, I want to take the 800, that 800 alone for training, and remaining 200 I want that alone for testing. You can go with random state, any random number. And if you want to shuffle it, you can go with shuffle equal to true, and there is something known as stratify. So stratify, if you are using this, you can go with the output. Stratify equal to y, you have to set it, what it is. If your data set, for example, here the Titanic data set, the survived, okay, Titanic dot survived dot value underscore counts. Okay, see here it is 0 in 49 places and 1 in 342 places. Now it's okay. For example, if you are having another data set where you are having 0 as 10,000 and 1 is nearly 300 only. Okay, in 10,000 places it is 0 and in 300 places only it is 1. So obviously the machine learning model is going to place a weight on this 0 because it is the highest value. So in that case, if your data set is imbalanced, okay, if the output is imbalanced, then you can go and mention this stratify. Here, comma, stratify equal to y. If you mention that, it is going to take them equally. Okay, 300, 300. Clear? So that's what this train test parameter will do. For example, if I want to go and use train test split, I have to just take the x and y first. So first let me go and go with Titanic.head. So before going into train test split, you have to do all the pre-processing like scaling or like imputation, handling the null value, outlier detection handling, okay, encoding, all these things should be done. Now I'll show you how to use this train test split alone. Once you've done that, in X, what are the important features? You have to select, okay, this passenger ID is just a number and it don't have anything with the survived, okay. Their age or their gender or their passenger class may decide, because those are important features, based on it only they are surveyed or not. But this passenger ID or some other feature, they don't have anything to do, so you want to avoid them. Okay, so you will be selecting. So next we are going to see about feature selection, what all important. So first, manually you want to select which all things should be useful. In other features we will go with feature selection, we will discuss about it. So for example, if I want to take this Titanic, these are the features, right? X should be dot drop. So I want to drop passenger ID, comma, I don't want the output in the features, question in the, like I don't want the answer in the questions, right? So survive. So I want to mention the axis also, axis equal to 0, sorry it's 1, right? Column wise removal. Okay, now it's removed. So if you go with x dot head, those two columns won't be there because those are the features I'm going to give. So I have to do the pre-processing, just I'm showing you. Okay, for example, these are the questions. So in Y, I want the answer. The answer is Titanic dot what it is, survived. Okay, whether they have survived or not. So once I done this, I'm going to use from sklearn dot model underscore selection. This is not pre-processing, this is from model underscore selection, import train underscore test underscore split. Okay, so now I have to create 4 variable, x train, so this is a common format, x underscore train, x test, y train, y test equal to train underscore test underscore split. Okay, I have to pass x comma y comma, what I need to pass next thing, test underscore size, right? So I'll set this to 0.2. okay, random state, random underscore state, so I'll set it to 0 for now. So before going into this, I'll go with x dot shape. So So let us find what is the shape of it. Okay, totally 891 rows and 10 columns. Y dot shape. (891 rows, only one column. Why? These are the questions, these are the answers totally, right? 891 rows and 10 columns are the features. This is the outcome for all those 891 columns. So now what I am going to do, when I run this one, it is going to split them based on 0.2, which is 20% will be for training and testing. So I will show with print x underscore train dot shape, comma, print y underscore train dot shape. Okay, so it's just returning, so you can just go with this one. So if I get both of these two things, see here, 712 rows and 10 columns the question and their answer. So now the 891 from that to 80% is here for training. So when you go with this one, okay, x test dot shape and y test dot shape. So this is for testing, and you will be having the remaining rows. See here, from 891, 712 is for training, 179 is for testing. Okay, so that's what the idea behind train test split is. Is it clear till now? Can we go with feature selection? So once you split them into training and testing part, okay, before giving it to the model, you can also prefer to go with feature selection. So this can be done after training and splitting. Okay, so this feature selection will help you to find what all the features important. For example, once I done all the handling in X, I am having this, right? So I want to, like, for example, I'll remove the name, I'll encode this to 1 0 and so on. So I'll remove these things and what all things require. So finally I'll be having some row columns. For example, if I'm having 10 columns, if I want to find what all the important column for my result, okay, in that 10, if I want only 5 which are important, I want to pass that for the model. So what I can do, I can go with feature selection. Okay, the features, the questions, important questions I can give to the machine. So that's what this feature selection is. It is the process of reducing the number of input variable when developing a predictive model. So it is desirable to reduce the number of input variable to both reduce the computational cost of modeling and also in some cases to improve the performance of a model and get rid of the noise. Okay, so these are the methods. So totally there are 5 methods. See here, dropping constant features, correlation method, mutual information, chi-square test, ANOVA F value. So these are some of the methods which you can find what are the important features from your data. So you can pass that alone to the machine learning model. So once we cover all these topics today, from tomorrow we are going to see or learn about machine learning model. Okay, we'll start with learning about the math behind the model and then implementing it in project. That's how the structure is going to be. Can we start with this one, feature selection method? First one is dropping constant feature. So for example, if one column is always common, okay, if you are having a column and its value is constant in all the place, all the row, so it is not obviously going to decide anything in your data, okay, because it's the same for everyone, so no issue. So you can just remove it. So how to do it? It can be done with the help of variance threshold from sklearn. So in this, if you want to give some other threshold value, you can give it also. Like if it is constant, you can give it a 0. If you want to find a 0.2, okay, what all columns which have 0.2 changes, you can remove it, you can go with threshold value. So from sklearn.feature underscore selection, import variance threshold. Okay, so I'm creating an object and I'm giving the threshold value here, so I fit it. Once I fit it, I can go and get underscore support. So what this will do, I'll tell you. I'll give you the simple example. Okay, we'll start with day 9 here. Import Pandas as PD, import NumPy as NP, import Cborn as SNS. I already have one data set. First I'll show you with some data frame, okay, then I'll go you and show this example with the data set which is totally having 370 column. Imagine 370 column, it's not row, it's column. So the data equal to pd.data frame, So I'll create a data frame using dictionary. See here, A. So this will have some values like comma B. Okay, so in the next column what I am going to give is, in C I'll give a standard, okay, only zeros everywhere or some common thing, okay, same thing everywhere. So that's what the constant is, okay. Fine, so I'll create it. I'll go with data.head. Now you can see it, right? 0 0 0 0 1 1 1 1. So if it is same like this, so what I'm going to do, from what is the tool we are going to use? From sklearn dot feature underscore selection import variance threshold. So I'll create an object where equal to variance threshold. Okay, so I'll pass the threshold value as 0. So wherever it is 0 difference, I'm going to remove that. So I'm going to just fit it. Now I'm going to fit the data. So if I run this, okay, it ran now. So what I'm going to do using variance dot, okay, get underscore support. So this is the option. Once you fit it, you can go and get underscore support, and it is giving me an array with boolean. Okay, it is true true, false false. So what does this mean? You can see it, right? True true, false false, which means if the output is true, then it is an important feature. If the output is false, which means the threshold value got accepted and it is removed. Okay, you can actually go and see like this, data.columns. I'll pass it as a filter. Actually the column A and B are important feature. Okay, this C and D, they have threshold of 0. Okay, they don't have any change in all the place, so that got removed. Clear? So now we can see a practical example. This is a data set from some customer thing. Okay, it's from a company. So I'll create data equal to pd.read underscore csv. So it's a big data set. Let it load. Okay, data.shape. So as I told you earlier, this contains nearly 371 columns. Imagine 371 columns. It is like nearly 76,000 rows and 371 columns. So I cannot give this 370 columns to my machine learning model. Okay, those are very large and it's going to be computationally very costly. So I want to select. Okay, I cannot go and manually select also. This is 370 columns. Okay, so what I'm going to do is I'm going to use this variance threshold for now. Data.head. So this is where that comes into play the feature selection. Okay, if you have this kind of thing, see here there are many things. So it's skipping many. You can go with the data.columns, which is actually going to give you the entire thing. Okay, so it's combining them, totally 371 the length is. So now I'm going to use this same thing. Okay, so I'll paste it here. So before that, I'll separate the x and y. So the final output will be the target. Okay, so x equal to, so I want to perform the train test split, then only I have to pass the x train value. So now I'll just give data.drop target, the final column, comma axis equal to 1, and in y equal to data.target. Okay, from sklearn dot model underscore selection import train underscore test underscore split x train x test y train y test equal to train underscore test underscore split. Okay, x comma y comma test underscore size equal to 0.3 and random underscore state equal to 0. So I'll run this. It ran. So now we got the x train. Okay, so then I'm going to fit for x train value, x underscore train. So what is this x train? How many columns it have? X train dot shape. Okay, 370 columns it is having. So I'm going to set the threshold value as 0 and I'm going to find how many is having 0 so I can filter it. So it is done. So now I can go with dot get underscore support, right? So it is going to give me a boolean. Okay, there are faults in some places. So I can go with length of this one. Okay, it's totally true equal to true. Can we get how many true value? Is it possible? No. So I'll go with x underscore train dot columns and I'll pass dot get underscore support. Okay, totally 332. Now it is reduced to 332 from 370. Okay, the remaining like nearly 40, it had threshold variance of 0, so it is removed now. Okay, you can set it like 0.2. If I run this, so now we will see like wherever the column the values is 0.2 variance, I'm going to remove that. So if I go and get this now it is reduced to 204. You can actually set, like for example, I want to set the variance as 1. So with that I can like minimize the important features. Okay, so now it's reduced to 178. So there are some other methods also which we can do. So this is how we can use this variance threshold method. Clear? Clear with variance threshold? Can we go with next one, correlation method? Can I get response from you guys? Is it clear? So these are kind of little bit advanced topics. So now it's a little bit confused because we are seeing all these things separately, right? Standardization and then all those encoding, all these things separately. So finally, once we done this, we are going to see projects where we'll apply step by step. There you can use all these things you have learned. Okay, it will be clear at that time. Can we start with next method? It is known as correlation method. So the idea behind this method is to remove all the columns which are highly correlated. Why? So what is a correlation? How one column is related with the other column. Okay, how one column is related with the next column, it is known as correlation. So there are positive and negative correlation. So we typically, so why we are doing this? So if it is highly correlated, so what I can do is I can remove that column. Okay, because if it is highly correlated, then the output it is going to be same. Okay, so if it is not correlated, then it can be an important factor. So based on it, I am going to remove the columns which are very correlated. So we typically set a threshold value for the correlation coefficient, and only if the features have a coefficient greater than the threshold value, it's going to be the target variable. Okay, so how to do it? I'm going to create a function for it. Okay, I'm asking for the data and the threshold value. I'm creating a set, okay, empty set in this variable correlation underscore column. So I'm getting the correlation from Pandas, right? .corr. So I'm going to use a for loop for I in range the length of column. For example, in this we got 370 column, right? So it is in the length 370. So totally it will from the range 0 to 370. So for that, for each one, okay, I'm going to go inside next one. I'm creating another for loop. For example, first time it will be 0, here also 0. Next one it is 0, 1. Next it is 2, 0, 1, 2. So in that case, it is going to take, okay, one by one, which means it is going to take each row, each element. Okay, it is going to go row column wise and take everything. So that's what will happen when you use this kind of nested loop. Finally, I am going to use ilocate for this I and j value. So I am going to get that exact value which is present, and if it is greater than the threshold value, I am going to get the column name and I am adding it with this set. So finally I will be getting a unique set, is unique, right? So finally I will be getting the column names which are closely related if it is greater than the threshold value. The threshold we commonly set is 0.7, okay, and we are getting absolute value, which means the correlation can be a positive one or negative one, but if you pass it in this absolute, it is going to turn them into positive value. So if it is greater than 0.7, the correlation is ranged from 0 to 1 or 0 to minus 1. Since we are converting it to plus, it is 0 to 1. If it is 0, which means there is no correlation. If it is 0.5, then it is like medially correlated. If it is greater than 0.7 or nearly or 1, it is highly correlated. So I just want to take the values which are greater than 0.7. Okay. So I am just going to repeat this for my data. So I'll create a function. So this is known as Pearson correlation. Okay. The correlation you are getting is the name for it, data and threshold. I'll ask this as a features argument. Okay. So the column names, I'm going to create an empty set here. The correlation I can get it from the data dot cor. Okay. For x in range, length of the correlation dot columns. So with this, I'm going to create a nested loop for y in range of x. Now, if the absolute value, I'm going to convert everything into positive value. I'm going to take one by one correlated dot ilog using locate 0. I mean, like x comma y is going to get you one by one. If the value is greater than, okay, this absolute value, if it is greater than the threshold, okay, then so the column name I can get it from correlation dot columns, the name of x, and I'm going to add it to the correlation underscore column dot add, since it is a set, right? So I'm going to add this column name if it is greater than the threshold value. Finally, once all of this is done, I'm going to pass it return correlation underscore column. So let me run this. So now we can pass this data, I hope so, x train, right? So Pearson underscore correlation x underscore train, comma, the threshold I'll set this to 0.7. So it's running, we'll wait to see the output. Since it is a lot of row, it is going to take some time, many rows and columns. This is a huge data set. Okay, so we got these are all very correlated. Okay, we got only the name of the columns which are highly correlated. So correlated equal to, so it is just returning the output, right? It is a set, so I can go and get the length of it. Once we get it, we are just returning it and storing in this variable. Once it is done, I'm going to print the length of it so that we can find how many columns are highly correlated with the threshold value of 0.7. Okay, it's done. Print length of correlated. From the, okay, totally it is 370, and in that 232 columns are highly correlated. So if you remove this thing, the remaining thing will be, or which are not correlated, which means they are important factor in deciding the output. Okay, so that's what the idea behind this correlation method is. Clear? So next will be mutual information method. Can we see it, guys, or can we skip it to tomorrow's class? So we have to see about mutual information method, and it is separately for classification and regression, and then square test, ANOVA F value. So we'll cover these three in tomorrow's class, and with that we are going to start with the machine learning algorithms. Okay, next step will be, once you do all these things, the next step it is going to be algorithms. So you have to choose it. So how will you choose it? You have to know about the algorithm first. So we are going to start tomorrow's class with these things. Once we complete it, okay, we are going to start with the machine learning algorithm. We are going to see about supervised machine learning, and in that classification algorithms. So there are many classification algorithms are there. What is the math and statistic behind it? We are going to learn about it in tomorrow's class. So if you guys have any doubt, or if you want me to repeat any topic, you can ask me now, or we can wind up today's session with that. Clear, guys? Any doubt in the topic we have seen today? Today we have seen about handling the outlier and then moving into train test split, and then regarding the feature selection we have completed the variance threshold and correlation method. Next we have to complete other methods which will be mutual information, okay, then chi-square test and ANOVA test. Based on it we can find which are the features which are important. If you want to reduce the dimensionality, you can go with this one. Can you please mention which method I want to repeat so I can teach you once again with that? Which method? The name of it, please. Variance threshold. Yeah, I can do it. So what is this variance threshold is? Okay, threshold value, variance threshold. You can see with this example. See here. So variance is like what is the difference or the value. Okay, if it is, see here in this column the variance is 1, right? Why? 1 2 3 4 5. Okay, it is going in that order. Okay, the change or difference is 1 here, that is the variance here. When you go for these two columns, see here it is 0 everywhere. Okay, or if I have 5 in all the places. Okay, this is the entire data set I am having. This is just 5 rows. Okay, and here it is 0 because there is no difference here. In this column also there is 1, but if you subtract and find the difference, there is no difference, right? That's what the threshold value is. So if I set this to 1, for example, see here, I'll run this. Okay, this is different data. Now I'll reload this one. I'll run this. So now I got this data, so I'm going to set the threshold value as 1. So I hope this column will go on. Okay, we got the same thing, more than 1 or 2 for example. Okay, same thing. But the thing is, see here, it is 0 everywhere and it is 1 everywhere. If you set the threshold as 0, which means it is not changing. Okay, so it won't be any important feature for the prediction. Okay, it won't decide the output, because if there is a change, then it may play a huge role in the prediction. But it is constant, right? Okay, so in that case you can go with variance threshold. If you set this to 0, if it is common or constant, it is going to remove that. Okay, so now if I go and get this variant dot get underscore support, so it is going to give me boolean value true and false, true false false, which means if it is false, okay, then it is going to be those having threshold as 0. Okay, so I can use it as a filter to get that. When you go for correlation method, I am just finding based on the correlation value. Okay, if I go with like this, I'll reload this data, so it is going to be a big one, this one. Data.correlation, so it is going to give me a table, right, with numerical value, and I am converting using absolute and turning everything into positive value. Okay, Wait guys, it's very big, so it is going to give you a huge table, and it will be a numeric value. And how this correlation table will give you, it is going to give you numerical value which is from the range 1 to -1, which means if it is 1, okay, if the value you got is 1, it means it is highly correlated. Okay, id with id, it is same, so it is highly correlated. Okay, if you got -1, okay, this is positive correlation. If you got -1, then it means highly negative correlated. If you got 0 somewhere, completely 0, which means there is no correlation between both. So I am just turning everything into a positive value, so that this negative values will be now in positive value, so it will be in the range 0 to 1. So I am just using a for loop, okay, nested loop using range, so that it can get from like 0, 0, 0, 1, and then 1, 0, 1, 1, and so that it will go through this 371, 371 entirely. So it is going to check, okay, wherever the value, I am going to set a threshold value. We got some value here, right? This 1, okay, it's this threshold value, it is greater than the threshold. 1 is greater than 0.7. So it is going to take that and give you that name, add it in this set. So it is going to do the same thing and take the column names which are highly correlated. So finally you will get the column name. See here, totally there are 232 columns which are highly correlated. So the thing is, if they are correlated or similar, it won't play much effort in the prediction. Okay, in the outcome, it won't play majority role. Only which are not correlated, which means they have some other property which may decide the outcome. Okay, that's why we are just neglecting the features which are highly correlated. When you got these kind of 370 rows, you can go, and there are some other methods also. We'll see that in tomorrow's class. Okay, clear? Here the change, okay, I am setting the threshold as 0 because the change here, it is no change at all. That is the threshold as 0, which means, okay, so it is going to take and search for it. If you find it, it is going to return a boolean. With that you can filter it. Clear now? That's it guys, thank you, thanks for watching. So there are some other methods also, advanced methods like chi-square test, ANOVA test, okay, mutual information. We'll see that, okay, in tomorrow's class. Thank you, thanks for watching. We'll see tomorrow's class.